Okay, so we're going to be working with exponential and log equations now. So we're going to be solving them and solving for x when it's an exponential equation or if it's in a log equation. So the first thing we're going to do is when it is an exponential equation and you're able to get the bases to be the same. So like for this one, I'm able to write 81 as 3 to the 4th, and that has the same base as 3 raised to the x. So I can get 3 raised to the x is equal to 3 raised to the 4th. And once I have the bases the same, now I can say that the exponents must be equal to each other. Because if 3 raised to the x is equal to 3 raised to the 4th, then that must mean that x is equal to 4.
Cynthia Horvath, please report to the front office. Cynthia Horvath, please report to the front office.
Hey. Will you open my door for me?
Yeah.
Am I going tonight?
Yeah.
Yes.
Yeah, I'm still open.
What's yours? Wanna wait? Thank you. So here's another one. 5 raised to the 7 minus x is equal to 125. And because I have 125 and I need it as a base of 5, I can write that as 5 raised to the 3rd. So then 5 raised to the 7 minus x is equal to 5 raised to the 3rd. So 7 minus x is equal to 3. And then I can solve for x, subtract 7, divide by negative 1, and x is equal to 4. So here's one more. 1/2 raised to the 4y is equal to 16. Well, I can get 16 to be 2 to the 4th, 2 raised to the 4th. And 1/2 is really just 2 raised to the negative 1. So then that's going to be 2 raised to the negative 4y is equal to 2 raised to the 4. So now I can say that negative 4y is equal to 4, divide by negative 4, and y is equal to negative 1. So here we get to some that you can't necessarily get the bases the same. I can't get 16 to be a base of 5. So there's a couple different ways you can do this, and the way I'm going to do it the first time, is I'm going to change it to log form. This is in exponential form, so when I change it to log form, it's going to be log base 5, then go away, of 16, then come back is equal to 3x. So change it to log form, keep the base, then go away, then come back. That's my little saying. However you remember to change it from exponential form to log form. And then what I need to do is use the calculator to find log base 5 of 16. And if you don't have a calculator that you can actually change the base, you're going to have to know the change of base formula. And even if you do have a calculator that can change, that you can use a different base, you're going to need to know the change of base formula. So if you have log base b of a, using the change of base formula, it's going to be log of A divided by log of B. You could also use ln of A over ln of B. It's just any log, but the ones in scientific calculators would be the common log or the natural log. So you find log base 5 is 16 in the calculator. You could use the change of base if you need to, and that's equivalent to 1.7227 and so on is equal to 3x, and then divide by 3, and I get x is approximately 0.5742. So here's another example, and I'm going to do this a different way. Because it's a base 4, what I can do, if I can get that to be log base 4, and I can take the log with the base 4 of it, because the bases are the same, I can get that whole log to equal whatever the exponent is, which is 3x plus 2. So that's equal to 71. But if I take the log base 4 of the left side, I would need to take the log base 4 of the right side. And log base 4 of 71 is equal to 3.07 and some change. Then just solve for x. So I'm going to subtract 2. And I get 1.07 and change, divide by 3, and x is approximately 0.3583. So you can do it either way. You can take the log of both sides with the base of whatever the base is in order to basically cancel out that exponent, or you can just change it to the log form. So for this next one, e raised to the x squared is equal to 16. Because it's e, what I'm going to do, change it to log form, and log with base e is going to be the natural log. So ln of 16, log base e of 16 is equal to x squared. And what I can do there is take the square root of both sides, and then I have x is equal to, because I took square root of both sides, remember the plus or minus, and it's 1.6651. Now we're going to get into log equations, and we're going to use our log properties. Because there's logs on both sides here, what I'm going to do is combine it so I have one log on each side. So I need to combine the left or the right side. The left side is going to stay the same, log base 4 of 2x minus 3. But the right side I can combine to be one log, log base 4 of x times x minus 2. And then I'm going to simplify that. So that becomes log base 4 of x squared minus 2x. And because I have one log equals another log, so the log base 4 of 2x minus 3 is equal to log base 4 of x squared minus 3. What that means is that 2x minus 3 is equal to x squared minus 2x. And now it's just a quadratic equation that I can solve any way I can solve a quadratic. So get everything on one side, add 3, subtract 2x. So I have 0 is equal to x squared minus 4x plus 3. And I can factor that into x minus 3 times x minus 1. So that means that x is equal to 3 or 1. But in this one, you're going to need to check for extraneous solutions. And in order to do that, basically all you're doing is you're plugging it back in to any of the logs. So when I plug in when I plug in 3 into the first log, I'm going to get 6 minus 3, and that's positive, so that's okay. When I plug it into the second log, log base 4 of x, it's log base 4 of 3, that's okay. And when I plug it into the third log, the x minus 2, that would be okay as well. So the 3 is good. When I plug in the 1 though, when I plug it into the 2x minus 3, that's going to be 2 times 1 minus 3 is negative 1. That doesn't work. The second log is okay, log base 4 of x, because that would just be log of 1. But the last one, I plug it in, log base 4 of x minus 2, so that would be 1 minus 2, which would be negative 1, and that doesn't work. So it doesn't work for those two, which means the 1 is extraneous. So that means that my only solution is going to be x equals 3. And here's another log equation, but I have a constant in this one. So I can't get it to be like I did the last one where it's one log equals another. But I'm still going to combine the two logs that I have. So that's going to be log base 3, they both should be base 3, of 9x. And because that is subtraction, it's going to be 9x divided by x minus 8 is equal to 4. And now what I have it in log form, so what I can do is change it to exponential form. Keep my base, raised to the 4th is equal to what's inside that log, 9x over x minus 8. 3 raised to the 4th becomes 81. And now I can solve for x. So I'm going to multiply both sides by x minus 8. And I get 81x minus 648. The x minus 8's cancel out here is equal to 9x. And then solve, so I'm going to subtract 81x. Negative 648 is equal to negative 72x, and divide by negative 72, and I get x is equal to 9. Just to make sure, if I plug that back in, it's not going to make either of the logs a negative, so that's good. So in this case, I have a log with base e, the natural log, so I'm going to change it to exponential form, keep the base, which is e, raised to the 7th is equal to 3 minus x squared. So now when I go ahead and try to solve this, I'm going to add the x squared so I can have that be positive. X squared minus e to the, plus e to the 7th is equal to 3, and then subtract e to the 7th, and I have x squared is equal to 3 minus e to the 7th. Well, because when I do e to the 7th, that's 1096.63, and 3 minus that is going to be a negative number. I won't be able to take the square root of the negative number, so what that means is there's no real solutions. So there you go. I'll have a joke for you in a second. Alright, what did the computer keyboard say to the typist? You better watch out, man. You're really pushing my buttons.